Welcome to my presentation and thank you for giving me a chance to present my topic in ACS Fall 2021. Today's my topic is fabrication and characterization of the physical properties of zinc oxide thin films in presence of isopropyl alcohol by Sealer method for photovoltaic application. I am Bijoy Ghos, one of the author of this work, and my paper ID is 3584304, and this is a collaborative work, Department of Chemistry, Cumilla University, Cumilla from Bangladesh, and Bangladesh Council of Scientific and Industrial Research, Dhaka, Bangladesh, Kumamoto University from Japan, and Saga University from Japan. Outline of the presentation. I will try to explain background of the study, motivation of the work, materials and method, resultant discussion, and finally conclusion. Now, the background of the study. On the right side of this slide, I attached a wood-jet zinc oxide unit cell structures, and the properties of the zinc oxide is that we know zinc oxide is a promising anti-windular material, and zinc oxide has a wide band gap of 3.37 electron volt, and it has a large excitation binding energy at room temperature, which is 60 milli-electron volt, and zinc oxide has a high transparency, which is greater than 80%, and it has a notable electron mobility, which is 155 centimeter per volt second, and it is favorable to form copper oxide zinc oxide heterojunction. Now, the motivation of the study. My aim is to study the effect of isopropyl alcohol and temperature variation on zinc oxide thin films and copper oxide zinc oxide heterojunctions when copper foil is used. Materials and method. First of all, the substrates. I use two types of substrates. One is soda lime glass substrates and another is copper foil substrates. The reason for choosing copper foil substrates is to see the formation of copper oxide zinc oxide heterojunctions, and the chemicals are zinc chloride, isopropyl alcohol, and ammonium hydroxide. Now, the methodology. We know a great number of methods are available to synthesize or for preparation of zinc oxide thin films. One of the method is Sealer method. Sealer means successive ionic layer adsorption and reaction method. The reason for choosing Sealer method in my work, because it is an easier fabrication method and it has less processing steps. It has a large area deposition and no sophisticated instruments is required for Sealer method, and Sealer produces durable and adherent thin films, and it has a low processing temperature. Now, the film deposition procedure. First of all, I clean the soda lime glass substrates and copper foil substrates using detergent and then dipping into toluene, isopropyl alcohol, acetone, and DNS water for 15 minutes in an ultrasonic assistant bath. After that cleaning, I dry both the substrates and preserve into a sample box. And then I made zinc ammonia complex solution by adding ammonium hydroxide to the zinc chloride solution. This zinc ammonium complex solution known as the precursor solution. The cleaning substrates then dipped into the precursor solution. Again, it dipped into the unheated DNS water. In that case, zinc hydroxide is formed. After that, two steps are followed. One is without sonication procedure and another is with sonication procedure. In case of with sonication procedure, after dipping unheated DNS water, I dipped into the ultrasonic assistant DI water. That means DNS water. And in that case, a great number of molecules is losses due to the vibration. And then I dipped into the isopropyl alcohol. Here, isopropyl alcohol maintained different temperature, which is 30 degrees Celsius, 50 degrees Celsius, and 65 degrees Celsius. And in that case, zinc hydroxide converted into zinc oxide. And again, I dipped into the ultrasonic deionized water. And in that case, a great portion of molecules which are loosely attached on the substrate surface are removed, and the quality of the thin films of zinc oxide are not good. For that reason, I eliminate the ultrasonic deionized water steps in case of without sonication procedure. In case of without sonication procedure, after dipping unheated deionized water, I dip into isopropyl alcohol. Where isopropyl alcohol maintain a different temperature. That means 30 degrees Celsius, 50 degrees Celsius, and 65 degrees Celsius. And in that case, zinc hydroxide converted into zinc oxide. And then I dipped into the normal deionized water, and the quality of the zinc oxide is good than that of before. And the chemical reactions occurred in my procedure where when I ammonium hydroxide added to the zinc chloride solution, that means zinc ammonia complex is prepared, and this zinc ammonia complex gives zinc ion, ammonium ion, and the hydroxide ion. This hydroxide ion bind to the zinc ion to form the zinc hydroxide, and that zinc hydroxide converted into zinc oxide when I dip into the isopropyl alcohol. Now the resultant discussion part. This table represents the sampling details and the thickness in nanometer. I did my work at three temperature ranges, 30 degrees Celsius, 50 degrees Celsius, and 65 degrees Celsius. In case of without sonication, the thickness value is increasing when temperature is increases. It is same for uh, both soda glass substrates and for copper foil substrates. But in case of sonication, with sonication process, we see that the thickness value is in anomalous behavior because of when I dip the substrates into the ultrasonic assistant bath, a number of molecules losses due to vibration. For that reason, the thickness value don't maintain any increasing trend. Now the XRD graph and for annealed and unannealed samples grown on soda glass substrates and copper foil substrates. The first graph represent for soda glass substrates and second graph represent for copper foil substrates. From first graph, we see that a mm, mm, um, different plane around 100 and 002 and 101, which confirm the presence of zinc oxide, and it is a hexagonal wooded structure. And the peak at 002 plane for G5 and G6, that means isopropyl alcohol at 50 degrees Celsius, isopropyl alcohol at 65 degrees Celsius, and it is for any unannealed and for also anneal confirm the C-axis oriented zinc oxide thin films. And in case of copper foil substrates, we see that a number of peak for copper oxide, either it is cuprous oxide or cupric oxide, and also zinc oxide phase are present. That means copper oxide zinc oxide junctions is produced when the sample is annealing. That means anneal at 250 degrees Celsius in 1 hour. Now the crystalline size and the latest trends for anneal and unannealed samples for soda glass substrates and copper foil substrates are calculated, and this table represents that at isopropyl alcohol 50 degrees Celsius for soda glass substrates and for copper foil substrates, that means G5 and C5, the mean crystalline size is higher. That means for G5 it is 26 nanometer and for C5 it is 21 nanometer. Therefore, we see at 50 degrees Celsius and the highest crystallinity and minimum microstrain among all samples with 002 plane preferential growth. And therefore, it indicates isopropyl alcohol at 50 degrees Celsius for growing better quality C-axis oriented zinc oxide thin films without sonication procedure. Now the Raman spectroscopy for the samples grown on soda glass substrates and copper foil substrates. First graph represent for soda glass substrates and second graph represent for copper foil substrates. From first graph, we see that a peak at 394, 440, 574, which confirm the presence of zinc oxide. But in case of copper foil samples, we see that a number of peak for copper oxide, either it is cuprous oxide or cupric oxide, and also zinc oxide phase is present. That means copper oxide zinc oxide junction is produced when the sample is annealing. That means 250 degrees Celsius in 1 hour. We see that peak at 574, 569, and 434, 428, 496, 494, 407, and 410, and 439, and 414, which confirm the presence of zinc oxide phase, and the peak at around 284, 216, 145, which confirm the presence of cuprous oxide phase, and peak at 330, 328, 346, 298, and 626, 628 confirm the presence of cupric oxide phase. Also, peak for copper are present And we say that when the sample is annealing, that means C1 to C6 samples confirm the presence of copper oxide phase and zinc oxide phase also. That means Raman's signal confirm the mixture phases when the sample is annealing, and the junction is formed when the sample is post annealing, that means 250 degrees Celsius, and it is consistent with the excited result. Now the transmission and diffusion reflection spectra for soda-lime glass substrates and copper foil substrates. Since soda-lime glass substrates is a transparent, for that reason we took the transmission and diffusion reflection data. And as copper foil is not transparent like soda-lime glass substrates, therefore we took only the diffuse reflection data. From both the transmission and diffusion reflection data for soda-lime glass substrates, we see that the absorption is near 350 nanometer and 380 nanometer, which confirm the presence of zinc oxide. But in case of copper foil samples, we see that the absorption is near about 380 nanometer and 580 nanometer and 780 nanometer, which confirms the presence of zinc oxide, cuprous oxide, and cupric oxide phase. Now, the band gap energy is calculated from the transmission and diffusion reflection data for soda-lime glass substrates and copper foil substrates, and the first graph represent for soda-lime glass substrates and second graph represent for copper foil substrates. From first graph, we see that the band gap energy near about 3.35 to 3.37 electron volt, and it confirms the presence of zinc oxide. And in case of copper foil samples, we see that a peak around 1.65 to 2 electron volt, and this confirms the presence of copper oxide phase, and a peak around above 3 electron volt, and it is up to 3.37 electron volt, and it confirms the presence of zinc oxide. That means here zinc oxide and copper oxide phase are present, and copper oxide zinc oxide heterojunctions formed, and it is confirmed from the band gap energy. And this table represents the band gap energy and phase identification evidenced from the XRD and the Raman spectroscopy. From this table, we see that the band gap energy decreases when the sample is annealing. And in case of soda-lime glass substrates and in case of copper foil substrates, only a single phase, that means zinc oxide, is present. But when the sample is annealing, in case of copper foil samples, we see that a number of phase for either it is cuprous oxide or cupric oxide for copper oxide, and a zinc oxide phase also present. That means copper oxide and zinc oxide junctions is produced when we anneal the samples at 250 degrees Celsius for 1 hour. Now the scanning electron micrographs for the soda-lime glass substrates and copper foil samples using the isopropyl alcohol as a dispersion for various temperature, that means 30 degrees Celsius, 50 degrees Celsius, and 65 degrees Celsius. On the left side, I attached the soda-lime glass substrates SAM graphs, and on the right side, I attached the copper foil SAM micrographs. At 30 degrees Celsius, we see that it is a cotton-like shape, and it indicates the zinc oxide thin films at this temperature is not good in quality. And at 50 degrees Celsius and 65 degrees Celsius, we see that it is a compact in nature and spherical grain size, and it is uniformly distributed. And in case of copper foil samples, we see that some Obergon clusters are seen, and we can say that the formation of zinc oxide thin films is not only affected by the isopropyl alcohol temperature but also the substrate condition. And we calculated the grain size for soda-lime glass substrates, zinc oxide, and also for copper foil substrates. And the grain size for soda-lime glass substrates, which is around 260 to 300 nanometer, and it is 200 to 230 nanometer for copper foil samples. And we see that the grain size in case of copper foil samples is less than that of glass substrates. Now I try to explain the isopropyl alcohol mechanism. Why I choose isopropyl alcohol? We see some scientists who are Lee et al. And Shea et al. Try to use different types of dispersing agents like ethylene glycol and propylene glycol, and they find that and the quality of zinc oxide thin films is better above 95 degrees Celsius. But when I use isopropyl alcohol, I got the better quality zinc oxide thin films at 50 degrees Celsius. And the mechanism of isopropyl alcohol is that since it has an intermolecular hydrogen bonds, that means the hydroxyl group of isopropyl alcohol reacts through hydrogen bonding with zinc hydroxide species and are easily turned into the zinc oxide. And thus isopropyl alcohol, we say, acts as a better dispersion to form a compact and uniform surface morphologies. Now the IB characteristics curve for both of my samples is specifically for copper substrates. First graph represent for IB characteristics curves of a typical copper oxide, zinc oxide, gold structure under dark and white LED illumination, and cell under dark and white LED illumination confirm the photoresponse of copper oxide, zinc oxide junctions as a preliminary concept to make a copper oxide, zinc oxide heterojunctions. And graph B represent for IB characteristics curve of the zinc oxide layer with gold contact showing ohmic behavior, and graph C represent for the diffuse reflection at two different area for the same cell showing the formation of copper oxide layer in the copper oxide zinc oxide based heterojunction. And finally conclusion, and the XRD and Raman spectroscopy confirmed that post-annealing treatment of copper coil samples produced copper oxide zinc oxide heterojunctions, and the sample deposited at 50 degrees Celsius revealed the best quality film with a band gap of 3.37 electron volt, and SAM confirmed the compact and uniformly distributed grain surface morphologies. And this study proposed to deposit the films on soda-aluminum glass substrates and copper coil substrates by sonication-less sealer process. That means without sonication process, using isopropyl alcohol as a dispersion agent for highly oriented zinc oxide thin films. And we hope that this study will open up a new approach for growing zinc oxide thin films with less processing steps and solution processable copper oxide zinc oxide heterojunctions for diverse application. And thanks for listening, and thanks everybody.